This narration is based on the final accident report published by the National Transportation Safety Board. The findings and probable cause have been formally adopted. All information presented here comes directly from the official investigation record, Flight and Aircraft Overview, on July 6, 2013. A Boeing 777-200ER, operated by Asiana Airlines, was completing a scheduled passenger flight from Incheon International Airport in Seoul, South Korea, to San Francisco International Airport in California. The flight was designated Asiana Airlines Flight 214. The airplane carried 291 passengers and 16 crew members, for a total of 307 people on board. The aircraft bore Korean registration HL 7742, manufacturer serial number 29171, and had been built in February 2006. It was powered by two Pratt and Whitney PW4090 engines. At the time of the accident, the airframe had accumulated 37,120 total flight hours and 5,388 cycles during the visual approach to runway 28 left at San Francisco International Airport. The airplane descended below the visual glide path and struck a seawall at the approach end of the runway. The tail section separated on impact. The airplane then slid along the runway surface, rotating clockwise approximately 330 degrees before coming to rest about 2,400 feet from the runway threshold on the left side of the runway. A fire ignited from the area of the right engine after the airplane came to rest. The airplane was destroyed. 3 passengers were fatally injured. 40 passengers, 8 of the 12 flight attendants, and 1 of the 4 flight crew members received serious injuries. The remaining 248 passengers, 4 flight attendants, and 3 flight crew members received minor injuries or were not injured. Weather and runway condition. The weather at San Francisco International Airport was visual meteorological conditions. The Automatic Terminal Information Service broadcast reported winds from 260 degrees at 14 knots, visibility 10 statute miles, few clouds at 1,600 feet above ground level, temperature 18 degrees Celsius, dew point 10 degrees Celsius, and altimeter setting 29.88 inches of mercury. A later observation closer to the time of the accident reported winds from 210 degrees at 7 knots, variable between 170 and 240 degrees. Visibility remained 10 statute miles. Temperature and cloud conditions were unchanged, with the altimeter at 29.92 inches of mercury. There was no convective activity, wind shear, or turbulence reported in the area. Weather was not a factor in this accident. Runway 28 left at San Francisco is 11,870 feet long and 200 feet wide, with an asphalt and concrete surface. The airport sits at an elevation of 13 feet above mean sea level. A precision approach path indicator was available on the left side of the runway, providing a 3-degree glide path reference. The approach end of runway 28 left has a rock seawall at the water's edge. At an elevation of approximately 7 to 9 feet above mean sea level. Importantly, the instrument landing system glide slope for runway 28 left was out of service at the time, as noted in a published notice to airmen. This was due to a runway safety area construction project. The localizer component remained available. Approach setup and speed policy. The flight departed Incheon at 5:04 p.m. Korean Standard Time on July 5 and flew for approximately 10 hours and 23 minutes. The crew initially expected to fly an instrument landing system approach to runway 28 left. When they learned the glide slope was unavailable, Northern California Approach Control cleared them for a visual approach. 4 pilots were on the flight deck. The pilot flying was a first officer who was undergoing initial operating experience on the Boeing 777. The pilot monitoring was a captain who was serving as the instructor pilot for this training. A relief first officer occupied the observer seat. A 4th pilot was also present. The pilot flying had briefed for an instrument landing system approach. The transition to a visual approach occurred relatively late in the arrival sequence. Asiana Airlines standard operating procedures required that by 500 feet above ground level, the airplane be stabilized at the target approach speed on the glide path and in the landing configuration. If any of these criteria were not met by 500 feet, a go-around was required. The reference speed for this approach was 132 knots. The target approach speed was the reference speed plus 5 knots, giving a target of 137 knots. To understand what happened during this approach, it is important to understand the Boeing 777's automatic flight control system. The system has two main components. The first is the autopilot flight director system, which controls the airplane's pitch and roll. The second is the autothrottle, which can control engine thrust. These systems are managed through the mode control panel on the glare shield. Their current status is displayed on the flight mode annunciator at the top of the primary flight display. The autothrottle can operate in several modes. In speed mode, the autothrottle actively adjusts thrust to maintain a target airspeed. In thrust mode, the autothrottle commands a specific thrust level, but does not control airspeed. In hold mode, the autothrottle holds the thrust levers at whatever position the pilot has placed them. It does not control airspeed, and it does not command any thrust changes. The autothrottle remains armed in hold mode, but it is not actively managing anything. In idle mode, the autothrottle drives the thrust levers to idle. There is also a low airspeed protection feature in the autothrottle. This feature can automatically increase thrust if the airspeed drops below a safety threshold. However, this protection is inhibited when the autopilot flight director system is in certain modes, including flight level change speed mode. This inhibition would become significant during the accident approach. Second by second final segment with exact times and values. At approximately 4,000 feet mean sea level, about 14 nautical miles from the runway, the airplane had autopilot engaged. The autopilot flight director system was in lateral navigation and vertical navigation speed modes. The autothrottle was in speed mode, actively controlling airspeed at about 210 knots. As the crew configured the airplane with flaps, they began their descent. At about 3,000 feet, approximately 9 nautical miles from the runway, the airplane was slightly above the desired 3-degree glide path. The pilot flying selected vertical speed mode with a descent rate of about negative 1,500 feet per minute to correct back to the glide path. The autothrottle remained in speed mode, controlling airspeed at about 2,000 feet and 5 nautical miles from the runway. The pilot flying changed the vertical speed setting to negative 1,000 feet per minute. Then came a critical sequence of mode changes. At about 1,630 feet radio altitude, the pilot, flying selected flight level change speed mode on the mode control panel. His intention was to use this mode to reduce airspeed toward the approach speed. However, because the airplane was already below the selected target speed at the moment the mode engaged, the autopilot flight director system commanded a pitch up to capture the speed from below. Simultaneously, the autothrottle transitioned from speed mode to thrust mode. In thrust mode, the autothrottle was commanding a specific thrust level rather than controlling airspeed. At about 1,400 feet radio altitude, the pilot flying disconnected the autopilot and began hand flying the airplane. He also manually moved the thrust levers toward idle, overriding the autothrottle's thrust command. This manual override caused the autothrottle to transition from thrust mode to hold mode. In hold mode, the autothrottle holds the thrust levers at whatever position the pilot has placed them. It does not control airspeed. It does not command thrust changes. The autothrottle annunciator on the flight mode annunciator continued to display, but it showed the word hold. The crew did not recognize that the autothrottle had entered hold mode and was no longer controlling airspeed. The pilot flying later stated that he believed the autothrottle was maintaining the target airspeed. He did not realize it had entered hold mode. The flight mode annunciator did display the word hold, but the crew did not notice or did not understand its significance. The Boeing 777 autothrottle has a low airspeed protection feature that can automatically increase thrust if airspeed drops below a threshold. However, this protection feature is inhibited when the autopilot flight director system is in flight level change speed mode. Because the system remained in flight level change speed mode throughout the approach, no automatic airspeed protection was available. The airplane was descending toward the runway with no system actively controlling its airspeed or providing a low energy warning. The timeline of the final approach was as follows. At 11:26:37 a.m. Pacific Daylight Time, at 1,000 feet radio altitude, the airspeed was approximately 149 knots. The autopilot was disconnected. The autopilot flight director system was in flight level change speed mode. The autothrottle was in hold mode. Over the next several seconds, the airspeed continued to decay without the crew taking corrective action. At approximately 600 feet, the airspeed had decreased to about 142 knots. At approximately 400 feet, the airspeed momentarily reached the target speed of 137 knots. But because no system was commanding thrust, the speed continued to decrease. At this point, the airplane was below the standard stabilized approach criteria. According to Asiana's procedures, the crew should have been preparing for a go-around if the approach was not stabilized by 500 feet. The approach was not stabilized, but no go-around was initiated. At approximately 350 feet, the airspeed was about 134 knots, already 3 knots below target. The precision approach path indicator showed 3 red lights and 1 white light, indicating the airplane was below the glide path. The airspeed continued to decay. At approximately 200 feet, it had decreased to about 125 knots, now 12 knots below target. The enhanced ground proximity warning system generated a sink rate oral alert. The pilot monitoring called out sink rate, sir. At approximately 170 feet, the airspeed was about 122 knots. An amber low airspeed indication appeared on the primary flight display. The relief first officer in the observer seat called out the word speed. At approximately 100 feet, the airspeed was about 115 knots. The pilot flying advanced the thrust levers forward. At approximately 80 feet, the airspeed was about 112 knots. The stick shaker activated, indicating the airplane was approaching an aerodynamic stall. At approximately 60 feet, the pilot monitoring called go around. At approximately 30 feet, the pilot flying pressed the takeoff go around buttons. The engines began to spool up. The engine fan speed was at about 50 to 55% and accelerating. At 11:27:53, the airplane struck the seawall. At impact, the airspeed was approximately 106 knots, which was 26 knots below the target approach speed and 12 knots below the stick shaker activation speed. The engine fan speed had reached approximately 92% and was still increasing, but there was insufficient altitude and time remaining to arrest the descent. The entire airspeed decay from 149 knots at 1,000 feet to 106 knots at impact occurred over a period of approximately 73 seconds. Touchdown and structural failure sequence. The main landing gear and aft fuselage struck the rock seawall at the approach end of runway 28 left. On impact, the tail section separated from the airplane aft of the rear pressure bulkhead at approximately fuselage station 2188. The vertical stabilizer, horizontal stabilizers, and auxiliary power unit came to rest on the seawall and in the water. Both main landing gear assemblies separated during the impact sequence. Portions were found on the seawall and along the runway. The right engine separated from its pylon during the ground slide and came to rest on the right side of the runway. The left engine remained attached, but was substantially damaged. The airplane fuselage, now without its tail section, slid along the runway surface. It rotated clockwise approximately 330 degrees before coming to rest on the left side of runway 28 left, oriented roughly to the southwest, about 2,400 feet from the threshold. After the airplane came to rest, a fire ignited from the area of the separated right engine. The fire was initially fed by oil from the engine, but fuel leaking from the damaged right wing eventually sustained it. The fire spread into the aft cargo bay area and up through the cabin ceiling. It destroyed the cabin interior from approximately row 30 aft. The forward cabin ahead of row 30 was not damaged by fire. The flight deck was not damaged. Wreckage distribution and distances. The tail section came to rest on the seawall at the approach end of the runway, approximately at the point of initial impact. Both main landing gear assemblies were scattered between the seawall and the airplane's final resting position. The right engine was found on the right side of the runway. Debris was distributed along the runway from the seawall to the airplane's final resting position, a distance of approximately 2,400 feet. Both wings remained attached to the fuselage. The right wing showed significant structural deformation and fuel leaks. The forward fuselage structure from approximately row 30 forward remained relatively intact structurally. The cabin aft of approximately row 30 was consumed by fire. Injuries and the report's serious injury definition. 3 passengers were fatally injured. 1 flight crew member, 8 cabin crew members, and 40 passengers received serious injuries, for a total of 49 serious injuries. 134 passengers and 4 cabin crew members received minor injuries. 110 passengers, 4 cabin crew members, and 3 flight crew members were not injured. The National Transportation Safety Board defines a serious injury as one requiring hospitalization for more than 48 hours within 7 days of the accident, or involving bone fractures other than simple fractures of fingers, toes, or the nose. It also includes lacerations causing severe hemorrhage or nerve, muscle, or tendon damage, injuries to internal organs, second-degree or degree burns over more than 5% of the body surface, or verified exposure to infectious substances or injurious radiation. The 3 fatal injuries all involved passengers seated in the rear rows of the airplane. A 16-year-old female passenger seated in row 41, seat B, was ejected from the airplane through the ruptured aft fuselage. She was not wearing her seatbelt at the time of impact. She was found in the debris field on the right side of the runway. Her cause of death was multiple blunt injuries. A second 16-year-old female passenger seated in row 41, seat E, was also ejected through the ruptured aft fuselage. She was found lying on the ground on the left side of the runway near the airplane. She was alive after the ejection. During the emergency response, she was covered by firefighting foam, making her difficult to see on the ground. She was subsequently struck by 2 aircraft rescue and firefighting vehicles. Her cause of death was multiple injuries, consistent with being struck by a vehicle. A 15-year-old female passenger seated in row 42, seat A, remained in the airplane. She was likely struck by the door assembly or surrounding structure when it separated during the impact sequence. She sustained severe head injuries. She was evacuated from the airplane, but died 6 days later, on July 12, 2013. All 3 fatally injured passengers were part of a student group from China. Crew experience and duty context. The pilot flying was 45 years old. He held a Korean airline transport pilot certificate. His total flight time was 9,684 hours. His time in the Boeing 777 was 33 hours. He had previously flown the Airbus A320 for about 4,566 hours, the Boeing 737 for about 2,579 hours, and the Boeing 747 for about 1,467 hours. This accident flight was his 9th initial operating experience flight on the Boeing 777. It was his first visual approach to San Francisco in the 777. He had previously landed at San Francisco in the Airbus A320. The pilot monitoring was 49 years old. He also held a Korean airline transport pilot certificate. His total flight time was 12,307 hours. His Boeing 777 time was 3,208 hours. He had been a 777 captain since 2007. He had completed instructor pilot training about 1 month before the accident. This trip was his first assignment as an instructor pilot. His duty was to supervise and evaluate the pilot flying's performance during initial operating experience. The relief first officer was 40 years old. He had 4,557 total flight hours, including 1,413 hours in the Boeing 777. He was seated in the observer seat on the flight deck and was not part of the active crew during the approach. He was the first person on the flight deck to call out the word speed during the final moments. The flight crew had been awake for approximately 15 to 17 hours at the time of the accident. They had crossed 8 time zones, producing significant circadian disruption. The investigation concluded that fatigue likely degraded the crew's ability to monitor instruments, detect the decaying airspeed, and make timely decisions. Toxicological testing of the pilot flying and pilot monitoring was negative for alcohol and drugs, aircraft configuration and weights. The airplane was a Boeing 777-200ER, a wide-body twin-engine airliner. It was equipped with a Pratt and Whitney PW 4090 engine on each wing. The airplane had accumulated 37,120 flight hours and 5,388 cycles since manufacture. Maintenance, records, and airworthiness were reviewed and found not to be factors in the accident. Company landing, standard operating procedures and definitions. Asiana Airlines standard operating procedures required a stabilized approach by 500 feet above ground level. The criteria included being at the target approach speed on the published or visual glide path and in the landing configuration. If any criterion was not met, a go-around was mandatory. The company's procedures addressed automation management, but emphasized the use of the autopilot and autothrottle for approaches. The procedures for visual approaches did not clearly address how to hand fly a visual approach in the Boeing 777 using the precision approach path indicator as a glide path reference. Asiana's operational culture emphasized heavy reliance on automation. Korean aviation training generally emphasized automation-coupled approaches, such as instrument landing system and flight management system approaches over hand-flown visual approaches. The investigation found that the pilot flying was not proficient in hand-flying a visual approach in the Boeing 777. Asiana's Boeing 777 type rating training included limited training on visual approaches. The transition training from the Airbus A320 to the Boeing 777 did not adequately cover the differences in auto-flight system behavior, particularly the auto-throttle hold mode and its implications. Multiple Asiana pilots who were interviewed during the investigation stated that they did not fully understand the distinction between the autothrottle being armed in hold mode and the autothrottle actively controlling airspeed in speed mode. The instructor pilot training program at Asiana allowed newly qualified instructor pilots to begin supervising trainees in operational service without significant prior experience in the instructor role. The pilot monitoring on this flight had completed his instructor pilot qualification about 1 month before the accident. This was his first trip serving as an instructor pilot. The investigation found that his lack of experience as an instructor contributed to his inadequate supervision of the pilot flying during the approach. Landing gear description and findings. Both main landing gear assemblies separated during the impact with the seawall and the subsequent ground slide. Portions of the landing gear were found on the seawall and scattered along the runway between the point of impact and the airplane's final resting position. The gear separation was a result of the impact forces and was not indicative of any pre-existing deficiency. Flight control's findings, examination of the flight control systems not reveal any pre-existing anomalies or malfunctions. The autothrottle components were examined at the manufacturer's facility, and no mechanical failures were found. The mode control panel was examined and found to be functioning properly. The flight control surfaces and their associated actuators sustained impact damage, but showed no evidence of pre-impact failure. The autoflight system behavior during the approach was consistent with the designed logic for the mode selections made by the crew. Wing, fuel, and fire findings. Both wings remained attached to the fuselage throughout the impact and ground slide. The right wing sustained significant structural deformation and fuel leaks. Fuel from the right wing fed the post-crash fire after the initial ignition from the separated right engine's oil. The fire spread from the right engine area into the aft cargo bay, and then into the cabin through the ceiling structure. The cabin interior from approximately row 30 aft was destroyed by fire. The forward cabin and flight deck were not fire damaged. Engines and deferred items. Both engines were examined. The right engine had separated from its pylon during the ground slide. The left engine remained attached, but was substantially damaged. Neither engine showed evidence of pre-impact failure or malfunction. The engines were responding to the crew's thrust lever inputs and to the takeoff go-around command in the final seconds before impact. At the moment of impact, the engine fan speed had reached approximately 92% and was still accelerating toward go-around thrust. A review of the airplane's maintenance records, including any minimum equipment list deferrals, did not reveal any items relevant to the accident. Emergency locator, transmitter behavior. The report does not provide specific details about the emergency locator transmitter activation or behavior during this accident. Recorders and components sent for analysis. The flight data recorder was a Honeywell Model 4700 solid-state unit. It recorded more than 25 hours of data across 2,048 parameters. It was successfully read out at the National Transportation Safety Board Laboratory and provided second-by-second data for the entire approach and impact sequence. The cockpit voice recorder was a Honeywell Model 6022 solid-state unit. It recorded 2 hours of audio across 4 channels, capturing the captain, first officer, observer, and cockpit area microphone. The recorder was successfully read out and provided all flight crew communications, callouts, and alert activations during the approach. The enhanced ground proximity warning system generated a sync rate oral alert at approximately 11:27:34, about 16 seconds before impact. The autothrottle components, the mode control panel, and the flight data from the quick access recorder were all sent for detailed examination. No mechanical failures were found. The system behavior was consistent with the designed logic for the crew's inputs, evacuation, and emergency response details. The evacuation began approximately 90 seconds after the airplane came to rest. The captain initially delayed the evacuation order while assessing the situation and communicating with the air traffic control tower. A flight attendant opened door 1 left and initiated the evacuation before the captain gave the formal order. 3 exits were usable for evacuation. Door 1 left, the forward left exit, functioned, and the slide deployed normally. Door 2 left was used by some passengers. Door 3 right, on the right side aft of the wing, was also used. Some passengers exited through ruptures in the fuselage. 2 exits were rendered unusable by slide rafts that deployed inside the cabin. At door 1 right, the slide raft inflated inward because the door sill had been deformed by the impact, causing the raft to deploy into the cabin rather than outside. This inward inflating raft pinned a flight attendant against the galley structure. A passenger retrieved a crash axe from the flight deck and used it to cut the raft and free the flight attendant. At door 2 right, a similar inward inflation occurred, also pinning a flight attendant. Firefighters eventually cut this raft to free the cabin crew member. These 2 inward deployments blocked 2 of the evacuation routes. Doors 4 left and 4 right were in the separated tail section and were not available for evacuation. Door 3 left was blocked. 5 passengers in the rear cabin area were unable to evacuate on their own. They were rescued by aircraft rescue and firefighting personnel who entered the airplane through the ruptured aft fuselage. The airport's aircraft rescue and firefighting station responded promptly. The first vehicle arrived at the airplane approximately 2 minutes after impact. Multiple units responded, including Rescue 10, Truck 10, Rescue 88, Engine 1, and additional units. Foam application began on the exterior fire. However, the emergency response had several significant deficiencies. The incident commander did not establish a comprehensive personnel accountability system. Firefighters and victims near the airplane were not all tracked or accounted for. Most critically, the 16-year-old passenger who had been ejected from seat 41E was lying on the ground near the left side of the airplane. She was alive, but covered in firefighting foam, making her extremely difficult to see. She was struck by 2 aircraft rescue and firefighting vehicles, Rescue 10, and then Truck 10. The drivers did not see her. The incident commander was not aware of her location. Radio communications were congested during the response. Not all units received clear instructions. The incident commander had difficulty managing the complex scene with its large number of victims. Entry into the cabin for interior firefighting and rescue of trapped passengers was delayed. The 5 passengers in the rear cabin waited a significant amount of time before being reached by firefighters. Triage was established on the runway. Mutual aid ambulances were called. The large number of 307 occupants strained the medical resources available at the airport. Investigation, focus areas, and analysis. The investigation examined the flight crew's management of the approach and auto-flight systems, the Autothrottle and autopilot flight director system design and mode logic, Boeing's documentation of the auto-flight system, Asiana Airlines training programs for visual approaches and auto-flight system operation, the instructor pilot training and oversight program, flight crew fatigue and circadian disruption, the survivability of the accident, including evacuation and emergency response, the slide raft design and certification testing, the aircraft rescue and firefighting response and incident command, and the medical response and triage operations. The investigation included Boeing 777 engineering flight simulator evaluations that replicated the accident approach profile. These tests confirmed that selecting flight level change speed mode while the airplane was below the target speed caused the autothrottle to transition to thrust mode and command a thrust increase. When the pilot then manually overrode the thrust levers to idle, the autothrottle transitioned to hold mode. hold mode with flight level change speed engaged. The low airspeed protection was inhibited. The simulator tests confirmed that the system behavior during the accident was consistent with the designed logic. The investigation's analysis concluded that the accident resulted from a series of interconnected errors. The pilot flying selected an inappropriate auto-flight mode for the situation. He did not understand or expect the resulting behavior of the autothrottle. He then overrode the autothrottle, unknowingly placing it in a mode that provided no airspeed protection. Neither pilot adequately monitored the airspeed as it decayed over more than a minute. The analysis also found that the go-around decision was critically delayed. By 500 feet above ground level, the approach was unstabilized. The airplane was below the target speed and below the glide path. Asiana's procedures required a go-around at that point. The crew continued the approach. The pilot monitoring did not call for a go-around until approximately 60 feet above ground level, just 5 seconds before impact. The pilot flying activated the takeoff go-around mode approximately 3 seconds before impact. By then, there was not enough altitude or time for the engines to accelerate and arrest the descent. Regarding the auto-flight system design, the investigation found that the flight mode annunciator display of hold was not sufficiently prominent to alert the crew that the autothrottle was no longer controlling airspeed. Boeing's flight crew operating manual did not clearly describe the hold mode behavior or the conditions under which the low airspeed protection would be inhibited. The autothrottle system had many mode combinations with different behaviors, and the complexity of these interactions was not adequately communicated to pilots through training or documentation. Regarding the slide raft failures, the investigation found that the certification testing for emergency slide rafts did not account for the type of fuselage deformation that occurred in this accident. The door sill deformation caused the rafts to inflate inward rather than outward. The existing certification standards did not require testing under such conditions. Organizations assisting the investigation was led by the National Transportation Safety Board. Parties to the investigation included the Federal Aviation Administration, Asiana Airlines, Boeing Commercial Airplanes, Pratt and Whitney, the Republic of Korea Aviation, and Railway Accident Investigation Board, the City and County of San Francisco, and the San Francisco International Airport. Soft closing. The National Transportation Safety Board determined that the probable cause of this accident was the flight crew's mismanagement of the airplane's descent during the visual approach. The pilot flying's unintended deactivation of automatic airspeed control, the flight crew's inadequate monitoring of airspeed, and the flight crew's delayed execution of a go-around after they became aware that the airplane was below acceptable glide path and airspeed tolerances. Contributing to the accident were the complexities of the autothrottle and autopilot flight director system modes that were inadequately described in Boeing's documentation and inadequately emphasized in Asiana's pilot training. Also contributing were the flight crew's non-standard communication and coordination regarding the visual approach, the pilot flying's limited experience conducting visual approaches, the instructor pilot's inadequate monitoring of the pilot flying, and flight crew fatigue. Contributing to the severity of injuries were the deployment of 2 slide rafts inside the cabin that blocked evacuation exits, deficiencies in the incident commander's management of the emergency response, and the failure to ensure firefighter accountability and awareness of personnel positions, which resulted in an aircraft rescue and firefighting vehicle striking, and fatally injuring one of the passengers who had been ejected from the airplane. The board issued 27 safety recommendations to the Federal Aviation Administration. The board recommended requiring Boeing to redesign the Boeing 777 Autothrottle mode enunciation to provide more noticeable alerting when the autothrottle is not in a speed controlling mode. The board also recommended requiring Boeing to modify the autothrottle to provide low energy alerting and protection regardless of the autopilot flight director system mode, removing the inhibition during flight level change speed and takeoff go-around modes. Additional recommendations addressed enhanced training requirements for autoflight system mode awareness, improved training for visual approaches and hand flying skills, strengthened pilot monitoring responsibilities and call-out protocols, and a review of slide raft certification testing to account for fuselage deformation scenarios. To Asiana Airlines, the board recommended enhancing Boeing 777 autoflight system training with particular emphasis on autothrottle modes and hold mode behavior. The board also recommended improving visual approach training for all pilots, enhancing crew resource management training, including monitoring responsibilities and go-around decision-making, and improving the initial operating experience program for instructor pilots. To Boeing, the board recommended improving the autothrottle mode enunciation to make hold mode more noticeable, removing or modifying the low airspeed protection inhibition during flight level change speed and takeoff go-around modes, and improving the flight crew operating manual documentation of autothrottle modes to the Aircraft Rescue and Firefighting Working Group and the City and County of San Francisco. The board recommended improving incident command training, establishing procedures for accounting for all persons in the vicinity of an accident aircraft before vehicle movements, improving communication protocols for vehicle operations near the accident scene, and requiring ground-level searches before any vehicle repositioning. This concludes the narration of the National Transportation Safety Board's final report on the accident involving Asiana Airlines Flight 214 at San Francisco International Airport on July 6, 2013.